Hello, let us look at number 28 from the review questions here. As you can see, we have a tangent line segment making up a triangle outside of the circle. Now then, we can see that here, BG and then BF, they must be in the same length because those are tangent line segments from a point outside of the circle, so as CG and then CE. And lastly, AF and then AE. Now, among many, one thing that which we get to realize is AE is 20. That tells us that AF is also 20 as well. Then, as you can see, AB was 32 while AF is 20. Then what is FB? That's right, 32 minus 20 will get us 12. That gives us the hint on BG. BG will be 12 as well because those are same line segments. Now, likewise, EC is 24. That tells us that GC will be also 24 as well. Then the question is, what is the length of BC? Everything combined together. So we just have to add 12 and 24, which becomes 36. So that becomes our answer. All right. Let's look at number 29. So here we have AC is equal to 12 from here to here, and then BC is equal to 3. Now, and then DC is equal to 9. What is EC? So I'm going to call it as X. Now, if you remember the formula that's involved between two secants and a circle, if I have A, B, C, D, was equal to A times A plus B. The concept of A plus B is the basically whole secant line segment is equal to C times C plus D. Now, then using that idea, the formula here would have been 3 times 12, because 12 is the entire line segment. Now, is equal to X times 9. Then we get 36 is equal to 9X. Of course, we can divide by 9 on each side, getting X equals 4. So 4 becomes our answer. Similarly here, AE is equal to 4, while AB is equal to 12. Notice that AB is the entire line segment. And then DB is equal to 6. Now, what is OC? OC, I'm going to call this one as X. Notice that OC is equal to radius. That means OE would have been also equal to X as well, because that's also radius. Another thing that which we get to realize is this. Since DB is equal to 9, 6, then AD also must be equal to 6, because 12 minus 6 becomes 6. Then I think we are ready to make an equation here. It says outside times whole thing, so we get 6 times 12 is equal to outside, which is 4, times what's my whole entire value? Is equal to 4 plus X plus X. Now then, on the left side, we end up getting 72, which is equal to 4 times 4 plus 2x. Now, 72 then is equal to 16, because 4 times 4 plus 4 times 2x becomes 8x. Now, subtracting 16 from both sides, then we get 8x will be equal to 56. Now, dividing both sides by 8, then x will be equal to 7. So, that's how we can figure out this question. Alright, let's move on to the next question then. Number 31 here. PS is equal to X, and then PQ is equal to 3, and PR, which is entire line segment, is equal to X plus 18. Alright, now, one thing that which we get to realize in this case would have been this. When you have a tangent line segment and a secant, where this one is A and then B and then C, we have to realize it was A squared, which was equal to B times B plus C. Now, applying that idea, our tangent line segment is PS, which is equal to simply X. So therefore, our equation would have been X squared is equal to 3, which is the outside line segment, times the whole thing, which is X plus 18. Then here we get X squared is equal to 3X plus 54. Bringing both terms onto the other side, then we will get X squared minus 3X minus 54 would have been equal to 0. Then you can say that, hey, let's factor this one. Yes, X minus 9 X plus 6 is equal to 0. So therefore, X must be equal to 9 from the first factor, or negative 6 from the second factor. But the thing is, X here, which is the length of the line segment, cannot be negative, so therefore negative 6 will be cancelled. Then what is PS? PS was equal to X, so therefore PS would have been equal to 9. Alright, let's look at the next question here. So here we have AB is 8 and then AC is equal to 4. What is CD? So I'm going to call that as X. Using the same formula, we get 8 squared, which is equal to 4 times 4 plus X. Now, then in this case, what do we end up getting? 64, which was equal to 16 plus 4X. By subtracting 16 from both sides, then we get 4X must be equal to 48. By dividing it by 4, X would have been equal to 12, and that's exactly what we're looking for, CD, which was equal to X. Alright, let's go for a couple more questions. Here we have CE is equal to 10, and then ED is equal to 6, and AE is equal to 4, and what is the length of EB? So here, the relationship that which we have to realize is if I have two line segments cutting, I call this one as A, B, and then C and D, then we have to realize that A times B is equal to C times D. So here we get 4 times X equals 6 times 10, which basically we get to see that 4X equals 60. Then we're going to divide each side by 4. Then X must be equal to, that's right, 15. And that becomes our answer. Alright. Number 34. Here we have DE is equal to 2X plus 8. And then EC is equal to 3. AE is equal to 4X minus 3. And then EB is equal to 4. And using the same formula, we get to see that 2x plus 8 times it by 3 should be equal to 4x minus 3 times by 4. Alright, then what do we end up getting? When you distribute 3, then we get 6x plus 24 must be equal to 16x minus 12. So I'm gonna subtract 6x from both sides. Then we get 24, which is equal to 10x minus 12. So adding 12 on each side once again. Then we get to realize that 10x is equal to 36. So when you divide by 10 on each side, you get to see that x must be equal to 3.6. So that becomes our final answer. And I guess that's it. And I'll see you later. Bye-bye.